All right, today we're looking at rotations. Now, a rotation is an isometry. We remember what that is. All right, we've talked about it so many times. An isometry preserves congruence. It's going to keep the same size and shape from the pre-image to the image. We call these congruence transformations, also rigid transformations. That is an isometry. A rotation is an isometry. Okay? Now, it is very important to note that a rotation is a transformation about a point. There is such thing as a center of rotation that we have to be careful with. And the center of rotation is the fixed point around which a figure is rotated. All right? Rotations are assumed to be measured as counterclockwise unless otherwise stated. All right? So if they say 180-degree rotation, well, 180 degrees would be the same either way. 90-degree rotation, assume counterclockwise. All right, moving on. So, a few things here. For rotations around the origin, if we're looking at a coordinate plane, rotations around the origin with angles of rotation, they're multiples of 90, we can use these facts. Okay, so we're talking about 90 degrees, 180 degrees, 270 degrees. This is assumed to be counterclockwise. So if we wanted to go 90 degrees clockwise, we could go 270 counterclockwise. But 90 degrees about the origin, xy becomes negative yx. 180 degrees about the origin, xy becomes negative x, negative y. And 270 degrees about the origin, xy becomes y, negative x. Now, why is this important? Well, this is just incredibly helpful. It is incredibly helpful, and these are all about the origin. Okay, that's important too. So, it says triangle MNP has vertices M at 1, 1, N at 4, 3, P at 5, 2. Okay, we have that triangle. Graph the triangle and its rotation 180 degrees counterclockwise about the origin. Well, if we want to go 180 degrees counterclockwise, 180 degree rotation, xy becomes negative x, negative y. Okay, that was right here. 180 degrees about the origin, xy becomes negative x, negative y. See how easy this is going to make it? 1, 1 is going to become negative 1, negative 1. 4, 3 is going to become negative 4, negative 3. 5, 2 is going to become negative 5, negative 2 to give us our M prime, N prime, and P prime. So let's just plot these. M is going to now be negative 1, negative 1. N is going to be at negative 4, negative 3. And P is going to be at negative 5, negative 2. The center of rotation, again, was at the origin right there. And notice it's like we took that and we rotated it 180 degrees counterclockwise. Very easy if we know that rule. All right, now the fixed point doesn't have to be the origin. All right, it's helpful if it's the origin. It makes it easier if it's the origin, but it doesn't have to be around the origin. So if we're trying to rotate it 90 degrees, well, we can go 90 degrees to that center of rotation, and we can make sure that we are perpendicular to that center of rotation. The same distance to the center of rotation, and then 90 degrees that same distance away. We'll see a problem like that in a second. Also, another fact for us to know, if we want to rotate 180 degrees about some point, it doesn't have to be the origin, any point, A, comma, B. Well, our point is going to be translated, or it's going to be transformed 2a minus x, 2b minus y. Okay, so that's another really, really helpful fact. Write that down. We're going to use that also. So we want to rotate this point -3, 4 about the point -3, 6. So where's that? -3, 6. We want to rotate this 90 degrees counterclockwise about the point -3, 6. So the red point is the point that we actually want to rotate. And so I'm going to notice it is 2 units directly to that center of rotation, but then I want to go 90 degrees counterclockwise, which is counterclockwise against the clock. And I'm going to go 2 units away, because I went 2 units towards the center of rotation, 90 degrees. Now I'm going to go 2 units away from that, and my new point, so if this was my original point, my new point is now right there at -1, 6. That is my new point. It has been rotated 90 degrees counterclockwise. I want to rotate this point 7, 8, 180 degrees, 180 degrees around the center of rotation, -2, 3. -2, 3. Right there. Well, we can use that xy becomes 2a minus x, 2b minus y. This is what we just talked about back here. Xy becomes 2a minus x, 2b minus y. I kind of covered it up there. But we can use this rule. It's going to make it so simple for us. We just plug in. We know our point was 7, 8. Since a is -2, we have -4 minus 7. B is 3, which is going to be 6 minus 8, which gives us a new point of -11, -2. So -11, 11, -2 means our new point is out here. Doesn't that make sense? We've gone 180 degrees about that point right there. So it makes sense. Final example of the lesson. Look at this Ferris wheel. Find the angle of rotation that transforms M to M prime. Now, we could count up every single little distance between these baskets here and then realize this is a fraction out of 360, but I'm going to simplify this a little bit and cut this circle in half. I'm essentially going to ignore all of this down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces in this half of a circle. And this angle is 1, 2, 3, 4, 5, 6, 7 out of those 10 spaces. So this is some angle. This is representing some angle out of 180 degrees, because all 10 spaces would be 180 degrees. That's half our circle. But this is 7 spaces between M and M prime. So if I do this, do a little cross product, do a little math there. We get 126 degrees to take M, rotate it about this point, and get it to M prime. There's a rotation of 126 degrees.